So today we're talking about monomial factors of polynomials. Okay. First of all, what do we mean by factors? Anybody? What's the difference between factors versus terms? Yeah, Carolyn?
Terms are separated by addition.
Good. Terms are separated by addition, whereas factors are what's between two factors? There's a multiplication in there. Very good. Do you guys remember factors? So we want something as a product. So I wrote this down. But we're not talking about any sort of factors. We're talking about factors of a what? Look on the right side. Polynomials. Okay? So how is that going to be different? So let's take a look at our first example here. And what we're going to attempt to do is here. Sorry. What we're going to do is with this polynomial, do you see this is a polynomial, right? How many terms do I have in this polynomial, by the way? How many terms do I have? There are two terms. Well, I don't see any addition sign. Well, yeah, by the definition of subtraction, it really means 15x squared plus negative 9, right? So we have two terms. Now, what do we mean by, because if I just ask you, like, if I just gave you this, 15x squared, well, 15 is a factor, isn't it? Because it's 15 times x squared, isn't that right? And do you understand? Mm-hmm. But if I'm talking about the whole thing here, okay, clear? What do you think I mean by monomial factors of the polynomial?
Negative 9 is a polynomial, right?
Not negative 9. The whole thing is a polynomial because you have more than one term, right?
One term.
Okay, so what do you think I mean by, well, by the factors of polynomial? First step is, yeah, what do you think?
Is the monomial factor in this one, would that be 15?
No, the monomial factor of the whole polynomial would not be 15.
Oh, okay.
Let me show you first step. So before we talk about this, by the way, what is the GCF of each of these terms? Because that's your step one. To find the monomial factors of a polynomial, you have to find step one. Step one, find the GCF. Let me see if I can hide it. Here you go. Find the GCF. What is the GCF of each of the terms? Anybody see it? Sometimes you could just see it without doing the factor tree, right? For this one, you could see it. Livy, what do you think? 3. How many people agree? Very good. Do you see how 3 is the GCF of each of the terms? Okay, this one is sort of easy to see. If you didn't see that, you could do a factor tree, right? 15 is what? 3 times 5. What's 9? 3 times 3, right? 9 is not 3. 9 is 3 times 3. So the right common factor is a GCF, not any kind of common factor. GCF is 3 for this, right? Now, every time, if you want to find the monomial factors of a polynomial, step 1 again is what? Finding the GCF. And isn't this what we've been doing many times? Right? We've done this, right? We had many practice. So then, how is that going to help us to rewrite this fraction as a product? Not fraction, this polynomial as a product. In other words, what does this GCF 3 do for each of these terms? It goes in to each of the terms, right? How many times does 3 go into 15x squared? 5x squared times. You know, it's kind of weird because you have x. You know what I mean? In other words, 3 times what gives you 15x to the second power? 5x squared. 3 times what gives you 9? 3. So knowing that, because we have found a number that goes into each of the term, we could write this as a product. Do you see what I'm talking about? Yeah. In other words, I could write this as 3 times something. I could represent this 15x squared minus 9 as 3 times something. What do you think that something is? I have it in the parentheses. Everybody, think about it as a group. I'll wait. What do you think? What goes into the... This is what you did on last night's homework. Think about it. 3 times what gives you 15x squared minus 9? Right? Didn't we do this last time on your homework? Think about it. 3 times what gives you this polynomial? That's what we're thinking. Here you go. See? Okay. Shh. All right. So, Carolyn, what do you think the answer is? Let's listen to Carolyn now. I think Carolyn got it. She was a bit confused. Now she understands. What? 3 times what gives you 15x squared minus 9?
5x squared
times negative 3. Times negative?
Oh no, subtract it.
5x squared. That's correct. Yeah, because what is 3 times 5x squared, class? 15x squared. What operation should come next if I want to make it look just like the polynomial before? Subtraction. And what do we need, Carolyn? What do we need next? 3. Do you see how I now was able to write this polynomial as a product? You see how this is called, we just factor this polynomial. Does that make sense? You see how we factor this polynomial? By the way, what does this remind you of? Distributive property. No, we don't have distributive. No. Backwards, right? Distributive property, right? Yeah, we don't have distributive property of multiplication. It's just called distributive property. All right, so distributive property, right? We're doing this backwards. If you don't believe me, multiply it back. What's 3 times 5x squared? 15x minus, yeah, 15x squared minus 9. Does that make sense? Do you see the kind of game we're playing? We're making, if you have a polynomial, we're using the GCF to rewrite as a product, meaning we're factoring this polynomial. Does that make sense? That's what we mean by monomial factors of polynomial. You see, the 3 is a monomial, isn't it? We were able to factor out that monomial factor from that polynomial. Does this make sense? Do you see why we spend many time figuring out what GCF of numbers are? Okay? This is when you're going to use this, okay? And you're going to use this factoring to actually solve equations later. Okay? Right now, do I have an equation? No. But if you don't know how to factor these expressions, you can solve equations involving these sort of polynomial. So that's what we're working on. Is that okay? So let's go to example 2 then. If you got this, I'm sure you could do example 2 without any problem. Okay? So again, on your homework, it'll say factor the monomial factor from this polynomial. Okay? It's going to basically they're going to say factor this. Okay? So we have 28x to the 5th minus 12x third plus 20x squared. Step 1 to factor this polynomial is look for the, what again? Greatest common factor. And it makes sense to find the greatest common factor because, right, that GCF will go into each of these terms, wouldn't it? So do we know how to find GCF? Yeah. So sometimes you have to do a factor tree and so forth, right? Sometimes you don't need to because the numbers are pretty simple. Okay, so go ahead and find GCF of each of these terms. Now, is x a common factor?
Yes.
Yes, it is. Look, x is in each of these terms, isn't it? And x to which power? Don't say it. X to which power should we choose? Go ahead, everybody try. I'll wait. Go ahead, everybody try. Don't say it. I said. Don't say it. Go ahead. So, how many people found your GCF? How many people wrote 4? That would not be correct.
4x?
It is 4. What? I just told you. Guys, isn't x one of the common factor? Yeah. Don't you literally see x in each of the terms?
Yes.
And isn't x squared the common factor, right? Because you choose the highest exponent or the lowest? The lowest. Lowest, so that it goes in all of these, right? X to the first will not be a greatest common factor. It will be a common factor, but we want to figure out the greatest, right? So x to the second, right? We choose the smallest exponent out of all these x's, right? Now, once we know that GCF is x to the second power, I want you to all then write this as a product, meaning factor this. What would it be? X to the second times what? Oops. Okay. I mean, yeah, you're right. So yeah, it'll be 4x. So step 1 we said 4x squared is the GCF. So it'll be 4x squared times what? Would give you that trinomial on top. Mimi, what do you think?
7x cubed.
Okay, 7x cubed. Good. Minus what?
3x.
Good.
Plus 5.
Good. And is there a way to check?
Yes.
How do you check? Yeah, you multiply it back and you should get what you had before. Do you think it's a good idea to check these really quick before you move on? Because if you messed up on one of the exponents, guess what? Yeah, the whole thing's wrong. Okay, be careful. Even though it's pretty simple, if you make silly mistakes like that, right, that's going to hurt you. Okay, so do you guys understand? Let's try one more then. If you really got this, you should be able to then do example 3. Okay, go ahead and factor example 3. Okay, how do you factor this polynomial? How many terms do I have, by the way? 2 terms, correct? Okay, go ahead. What's your step 1? Step 1 is to find the
Common factor.
not any common. You have to find the greatest common factor. Okay, you have to find the GCF. If it's not GCF, you haven't really factored. Does that make sense? If you just find any common factor, because I could just find 1. Isn't 1 a common factor? And I could just say, oh, 1 times this whole thing. Am I done factoring? No, you have to find the what kind of common factor? Greatest. Because if you don't find the greatest, then you're not done. It's not fully factored, okay? Everybody try. So, let me call somebody at random. Who thinks they know what to at random? At random. Okay, put your hands down. Let me see. Who should I pick for GCFs? How about Samira? What do you think? What's the GCF of these two? What'd you get? 5x squared y z is what she said, and how many people agree? 5x squared y z. You guys are all correct. Okay, so that's your GCF, right? Now, if that's my GCF, and we know how to do this, we've done this many times. That means 5x squared y z would have to go into both of these terms, right? So then we could rewrite this as 5x squared y z times something. What goes into the first term? Carly. Minus, hold on. Good, hold on. And then secondly, how about Christina?
4z.
4z is correct. You guys got it. Okay? Does that make sense?
Yeah.
How many got this? Raise your hand. Is this easy or hard? Can you do something like this for your homework?
Yeah.
Do you see why we practice finding GCFs?
Yes.
Do you see that? Okay, it's to do something like this. Okay, there are many other uses, but for this one. Okay, then we're gonna switch a gear a little bit. Okay, now and we're going to, and I want you to understand. And you may say, wait a minute, why are they talking about this all of a sudden when we're talking about monomial factors or polynomials? I want you to think, right, why they're giving you this sort of problem, okay? Even though it looks very different than what you might see here. Is that okay? So let me just give you the question. Hold on. So before I get going, let me ask you this. If this is a fact, isn't it? If I have a plus b over c, what was this fraction before it became a plus b over c? In other words, which two fractions did you add so that it became like Livy?
A over c plus b.
Exactly. Would you agree that this was really a over c plus b over c? Right? Because they have to have a common denominator to be able to add these two fractions, right? That's why the denominator stays as the c, right? Stays same. Everybody okay with that? Second fact that you should be aware of. What was this? A times b over c. How do we get a times b over c? Was it a over c times b over c? No. That would mean that you get ab over c squared, right? So please be careful. What does this mean? A times b over c. Matthew?
A over c times b over c.
Then you get c times c, you get c squared. Be careful. Okay, Matthew, say it again. Because if you did that, right, then you would get ab on the numerator, but what's c times c? That's c squared, isn't it? So how do I get c by itself? Not c squared. It would be a over c times what? B over 1. Does that make sense, Matthew? Okay, be careful, guys. So I wrote this down for you right here.
Wait, why can't
Could it also be a over 1?
Or it'll be, some of you said this. A over 1 times b over c. Same
What
thing.
would happen if you did it the same? Other than the fact that it would be wrong, but like, why can't you do it?
How? Jason, what do you mean?
I don't know. Never mind.
Yeah, because if you have c on the bottom, Jason, do you see the difference? Here, the first one was a plus b on the numerator. Here is a times b, right? So this means if you multiply two fractions, right, you multiply the numerators together and the denominators together, right? If you have c on the denominator and another c, you will get c squared. It will not equal to ab over c.
Okay.
Does that make sense? So be careful. A times b over c is really a over c times b over 1, or you could think of it as a over 1 times b over c, same thing. Now, why are we talking about this? Because like I said, we're going to do some different problems than we used to. Take a look at this problem. Okay, actually, let me move this up a little bit. Okay. So go ahead and write this down, and I'll move this up. Okay. Take a look at this problem now. You see, it's a little bit different than what we've been doing, right? All the other examples from 1 through 3, we factor out the monomial factor, right? Greatest common factor, right? Now it's going to say divide, or they could also say simplify this fraction. What would you do if I had 16y minus 12 over 2? Now think about those two facts we wrote down. This is sort of like a plus b over c, isn't that right? What was this, and how would you simplify this fraction? Or divide this fraction? Eric? This is...
We show the work.
Yeah, what kind of work would you show?
16y divided by 2.
Exactly.
Would be
And then?
multiply or add.
What do you think?
Add.
You think, okay, add what?
Negative 12.
Right, add negative 12 over.
Divide by 2.
Yeah, or I just wrote it as minus 12 over 2. Is that okay? Isn't that the same thing?
Yeah.
Right, you have two fractions subtracting. You have a common denominator of 2. So you get 16y minus 12 over 2. Isn't that the same as 16y over 2 minus 12 over 2? Right, and do we know how to simplify this? Yeah, what's 16y over 2?
8y.
Yeah, minus 6. Is this easy or hard?
Is that the answer?
Huh?
Is that the answer?
Yeah, this is the answer.
Oh.
So it's pretty simple. So why do you think and you may be saying, wait a minute, I thought our topic for today was monomial factors of polynomials, right? Why are we all of a sudden doing something like this, something simple? How is this related to monomial factors of polynomial? Anybody see this? Anybody?
Factoring.
How?
Simplifying.
Well, right now we haven't factored anything, have we?
Yeah.
Where? We haven't factored anything, have we?
Yeah.
Why do you think we're talking about? Why do you think this sort of problems is in your homework tonight when we're talking about monomial factors of polynomials? We haven't factored anything. We haven't, do you see any? We haven't really done it. Anybody see? It turns out, if you want a hint, we could actually use
Distributive property.
distributive property backwards, which means factoring out the GCF from the numerator to get the same answer.
Wait, but that sounds harder.
Yeah. So you may not do it that way, but I just want you to show that you could actually do it this way too. And this is sort of related. Here's what I mean by this. Look at the numerator. What is the GCF of the numerator? Let's factor that polynomial, right? Isn't it 2? Is it 2 or 4?
4.
It's 4, isn't it? Doesn't 4 go into 16 and 12? If you don't believe me, you could do a factor tree, right? Yeah, it'll be 4, isn't it?
Yeah.
So 4 times what gives you 16y minus 12, guys? 4 times, here's the second method. 4 times what?
What?
So this first step, we found the GCF. 4 times
4y.
4y. 4y what?
Minus
Minus 3, right? Isn't that what we get? Now, look at the fact 2 that you just wrote up there. This is sort of A times B over C. What does this really mean? 4 over 2 times what? 4y minus 3 over 1. Would you not agree? Right? What is 4 over 2? 2. And you say, wait a minute, we don't get the same answer as before. Yeah, we do. Right, we do. Why? Because all you have to do now is what, guys? Distribute 2 to 4y minus 3. What is 2 times 4y? 8y. Minus 2 times 3, which is 6. We get the same exact answer. So, we could use, right, factoring out a monomial from the polynomial to do the same exact problem. And Jason's right. You may not want to do it this way, right? The first method is a lot easier, right? But I'm just showing you that this is why it's there. Because some people always ask me, why do we even do this, right? All of a sudden, when we're talking about monomial factors of polynomial. Does that make sense? Do you have to do it this way, method 2? No. Could you do it if you wanted to? And do you think there'll be times where you might want to do it this way? Yeah, but let me see if you could figure that out. But you should be able to do it both ways. You could do it whichever way is easier. And I'm saying, there'll be times where you might want to do method 2. Okay? Method 1 may not be the easiest way. Anyway, is this okay? All right, let's move on then. Let's do this example 5 using method 1 first. Okay, go ahead. Everybody simplify or divide this fraction. 28pq minus 35p over 7p. Go ahead. I'll wait. 28pq minus 35p all over 7p. Okay. So here we go. So using method 1, we could just simply write this. Isn't this the same thing as 28pq over 7p? Right? Isn't it? Minus what? 35 over 7p. Isn't that right? Would you not agree?
Yeah.
So then what? So how would you simplify 28pq? Isn't the same as 20? Oh, I should write. Oh, give me a sec. I should write this down. Okay, so don't you get then 28? So could I rewrite this fraction as 28 over 7 times what? P over P times Q over 1 minus, what's this? 35 over 7 times P over P. Can't you do that?
Yeah.
So class, what is 28 over 7, first of all? 4. What's P over P? 1. 4 times 1 times, what's Q over 1? Q minus, what's 35 over 7? 5. What's P over P? So the answer becomes 4q minus 5. How many, raise your hand if you got 4q minus 5. Does this make sense? How else would you do it, Carolyn?
Yeah.
Yeah, I mean, I'm showing my work. Why we cancel things out, but isn't this how you do it? So, but this is how you show work, okay? Because if you don't show work like this many times, people will cancel out without really knowing what they're doing, right? And get it wrong. They would, okay? So please show work like this, okay? Now, could we have done it the other way, second method? Everybody try, go ahead. Try the second method where you factor out the numerator, okay? You could factor the numerator with the monomial, which is right? See if you get the same answer. I'll wait. Go ahead, everybody try. You should be able to do both ways, okay? So, oops. What was our GCF for the numerator? How about, hold on, how about, let me call somebody random. How about Song? What do you think? What was the GCF of the numerator? Shh. 4? 7 what? P. Wasn't it 7p? So if that's true, Song, 7p times what gives you, so method 7p times what gives you that numerator? 7p times what gives you, what was the question? What was we have on the numerator? Yeah. Okay, I'm hearing people helping. Okay, 4q minus what gives you the 5? Would you agree, guys? Yeah. And what do we have on the denominator? 7p. Isn't this nice? Because some of you now may like the second method. Now, if I know this, what's this? 7p over 7p times what? 4q minus 5 over? 7. Is it 7? 1. Because we have 7p as a new, right? So therefore, what's 7p over 7p? 1. Do we get the same answer as before? Yeah. Does this make sense? How many people like second method now better? I still haven't convinced you guys. Actually, okay. Let's try one more example. Is that okay? All right, here we go. Let's try one more. Okay, go ahead and try this example. 4x to the 5th minus 24x cubed y plus 10x squared y squared all over negative 2x squared. And I'm sorry?
I thought you wrote the other one as
Okay, yeah. So, question?
Do we have to do it both ways?
Not both ways, whichever ways you like. It doesn't really matter. You should get the same answer, right? So if you like method 1, do method 1. If you like method 2, you could try method 2. That's fine. Yes?
On the homework, can we do either way?
On the homework, they actually want you to do method 1 on your homework. But I'm just showing you, method 2 actually works too. Okay? So on your homework, you could just do method 1. Okay, that's fine. But just know that you could do, right, with method 2, where you factor out the GCF from the numerator and so forth. Go ahead, everybody try. But you should get the same answer no matter how you do it. Here we go. Try this. Okay, so who could tell me, first of all, let's separate them into 3 fractions. Is that okay?
Yeah.
So you get, how many people got this? 4x to the 5th over negative 2x squared, right? Plus, do you see how I changed this to addition?
Yeah.
Did anybody not do that, or did you?
I did.
Okay, if you didn't have to, but it's really nice.
But I didn't write the negative sign. I just did plus because I thought that.
Okay, negative over negative is positive. That's fine. And plus 10x. Okay, now somebody tell me what I get for my first term. Yes, Angel.
Negative 2x cubed.
Good. It's negative, right? What's positive over negative, guys? Negative, right? So you get negative 2x cubed. Oops. Then for the second term, plus or minus? Plus. Okay, how about Michael? 12 positive, right? Good. 12xy plus Bella?
Negative 5y.
That's right. So it turns out this one is much easier to do method 1, okay? You could do method 2 to get the same answer. But, okay, by the way, at the end I'm just going to write it as minus 5xy squared, is that right? So try example 7. Now this one, just do method 1. Because if you try to do method 2, it's sort of kind of hard. So just do method 1. Go ahead, everybody try. I'll move it up a bit. So try, here we go. Example 7. Like I said, if you actually try this with method 2, you have to sort of distribute at the end. So it may not be so fast. Just do method 1, okay? And on your homework, just do method 1. It's fine. Unless they ask you otherwise. Okay, so everybody go ahead and try this. But know that you could actually use method 2, okay? That's important. But try. Just separate it into 3 fractions and simplify each fractions, okay? Go ahead. Alright, so who can tell me how do we, so I put a star on this one. It's a little bit different than the other one, not that bad. So how many people got this? 6r cubed t over rt minus, I changed it to addition, okay? Minus, good. A lot of you, negative 18r squared over t squared over rt plus 3r over rt. First term, Claire, what do I get when I simplify?
6r squared.
You got it.
Got it.
Second term, plus, what does that become? How about, yes?
Negative 18
Negative
RT.
18 RT. Correct. Lindsay is correct. Then, next, Samuel. Okay, but we don't want negative exponents. What does that mean? When you have negative 1. T to the negative 1 power. No, the r's cancel out, don't they?
Yeah.
3, what? 3 over t. How many people got 3 over t? Okay, that's the answer, guys. So this one was a little bit different. You got it? Good job. So you get r over r, right? And 3 over t. How many people wrote down, hold on, shh. How many people wrote down 3t here? Me. Okay, okay, guys, you don't, sometimes you get fractions at the end. It's okay. Okay, so t was on the denominator. It doesn't just go to the numerator all of a sudden, does it? Okay, so it still stays on the denominator. Is that okay? Do you see why I put a star on this one right here? Okay, any question? Good.